Now the most important topic in C++ or object orientation, the very important topic of object orientation is polymorphism. Now let us see the example of polymorphism. So for that I will take one class, car. This is which car? Generic car, generalized car. I told you that a general term. For any four-wheeler which carries passenger, we say it's a car. So that car. Then it is having some functions: public, void, start, and it is having a message to display, that is car started. Car started. Then void, stop. There is another function and it is having cout, car stopped. Now this example is going to be a little lengthy and I am explaining and writing. See, this is a car and it is having start and stop functions and they are having some messages to give. Then I have a class called Innova and this is inheriting from car, public car. Then when it is inheriting from car, everything it will get it from there. But what are those things? They are just functions, start and stop. Do they have any role to play? No, they are displaying about car. So this Innova should override that one. Override that one. So yes, it will override the functions public, void, start, cout, Innova started. Then void, stop, cout, Innova stopped. That's it. So I have a class for Innova, right? Now I want to write one more class. There is no space, so I'll use this place for writing a class. Class Swift. This is inheriting from, again, car class, public, and it's having function void start, and it is displaying cout Swift started. Then it's also having a function void stop, and this function is displaying cout Swift stopped. So already I have taken this example when I was discussing specialization and generalization. So this example is for generalization. So do you think which class was existing? Innova was existing and Swift is existing. Then we said these are cars, so we have defined a class called car. So if I draw a hierarchy, it is like this. So there is a car class and from that Innova is inheriting and from that Swift is inheriting. So already you are familiar with, so I have taken a small diagram. Now you can observe one thing here is car class is having two functions. Then what is there with the car class to share with its children? Who is a child class? Innova. Who is a child class? Swift. Then is it having anything to share? No. Innova is overriding start and stop and Swift is also overriding start and stop. Then what is the use of that car class? What is the use of those functions? When it is inheriting from that class, it's not getting anything. It's not getting anything. Let us see. I will write on main function. See, in the main function, if I write a pointer of car class and object of Innova, I'll call a function ccap start. Now tell me which function will be called. Base class pointer, derived class object and an overridden function start is called. So which function will be called? This Innova or car? So you know it well. So car class function will be called. So you are saying, see, the vehicle in front of you is Innova, but you are saying it's a car and you're driving. So it drives like a car or Innova. Here it is driving like a car. So that's it. We are back on the same point. So what we are supposed to do? Suppose we want this function should be called, then we have to make this function as virtual. Then this also should be declared as virtual. So both these functions are declared as virtual. Now if I call ccap start, then Innova function will be called. Yes. So this means that the existence of that class is virtual, not real. not real. That I told you. We use the term shape as virtual. We use the term car as virtual term, not real term. It doesn't exist in real world. So that's it. So I have taken the same example and have shown you so that it matches with the real world. So and you get the sense out of this one. So you can practically use it somewhere. Now I'll continue with the main function. In the main function, I will say same C pointer and I will say new Swift class. So I am having an object of this class. Then I will say C start. Now tell me whose function will be called. Now the object is Swift, so this function will be called. See, it is just like this. I have a pointer of type car and the object is Innova, right? Then I call start, so Innova started. So here I'll get a message that Innova started, right? This is what I get. Then again next I have a Swift car. Then the same pointer is not pointing there, it's pointing here. Now C assign Swift. Then I said C start. So who will start? So here Swift started. See, pointer is same but the objects are different. When I call the function, what was the function? I can call start. First time this was started, then this was started. So depending on the object assigned to it, either Swift or Innova, the different functions are called in these lines. Here Innova function, here Swift function. Now if you see the lines, C caps start, C caps start, lines are same. Lines are same, but the functions called are different. That's it. This is polymorphism. We are achieving polymorphism. Same statement, car start, car start, car start, car start. But the function calls are different because here the object was Innova and here the object is Swift. So that's it. We have achieved polymorphism. So it means you can run any car if you have a pointer of car. You can attach the object of Innova or attach the object of Swift or Corolla or Amaze or any car model, right? What all the models you know in your country. You take the object of that one, pointer is car, call the function, start function is present here, right? It's a car means definitely present here. So that object function will be called. So that's it. This is the example of polymorphism. Now I can extend few more things on this. Then I can extend a little bit on this one. Watch it here. The very interesting thing. This is an example of generalization. Innova. Okay, I'll put a mark here. Okay. So this is an example of generalization. Which classes are already existing? Swift class is already existing. Innova class is already existing. Two classes are already existing. Then we have written a class called car. Yes. For what? To achieve polymorphism. So that we can call this Innova also as car and the Swift also as car. That's why we have defined it. Then you have written the common functions there. Yes, we wrote. Why did you write the code there? Is it useful? Are you going to use the object of class car? No. Then erase it. Okay, I will remove this. Remove this. Those are virtual functions. Yes. Do they have the body? No. What is the purpose? That is for just achieving polymorphism. Why you wrote that function? Because we want those functions must be implemented by subclasses. Now that became a superclass, parent class. We want those functions to be implemented by this one. You want to force the derived classes to implement or just their wish? No, we want to force. What we want to force? We want that any class says that inherit from car, then it must override those two functions. It must override those two functions. How to make it compulsory? How to make it compulsory? So you have to write equal to 0 here. Equal to 0 here. So these functions are called as pure virtual functions. When you assign a virtual function to 0, it's a pure virtual function. This is a pure virtual function. Pure virtual function. Pure virtual function means what? What is the purpose? Those functions must be overridden by derived classes. Otherwise, the derived class will become abstract. And that class car is actually abstract only. It's an abstract. you cannot create the object of that class, right? Because it is abstract. When a class inherits from that one, then this also become abstract if it is not overriding. So it must override. So we have said that those functions must be overridden. So pure virtual function must be overridden by derived classes, and the purpose of pure virtual function is to achieve polymorphism. You cannot create the object of car class. Can you create a reference pointer? Yes, you can have a pointer of car class. Everything works, same thing works. Now you can see that conclusion. I already have class Swift, already have class Innova, then I define a class called car, and I said that both are inheriting from that one. Then what that class has to give? Nothing, just the declaration of the function where the derived classes must implement those functions. So that's it. This is a very interesting topic, very important topic. So that's all. We will run this and see how it works.